In this question, we have to find out the allowed nuclear decay out of these 4 decays given in the options. So we can solve or check these equations one by one. So let's look at the first equation or first decay. So we can check all the quantum numbers. Let us say first check the charge. So it is 0 on the K and +1 and -1 on the muon particle. So charge is conserved. Let's also check the spin quantum number. So spin of the cation is 0. The spin of the muon particle is half and half. So on the right hand side, the possible combinations of spin gives 0 and 1 value. So which is matching with the left hand side. So spin is also conserved. Look at the lepton number. So L mu 0 for the kaons and -1 for the mu plus and +1 for the mu negative. It is also conserved. Isospin for the cation is half, but for the mu particle it is 0. So isospin is not conserved. The third component isospin for the K0 it is -half, and again for the muon it is 0. So I3 is also not conserved. Let's look at the strangeness also. So strangeness of the K0 is +1, and for the muon it is 0. So delta S is also not conserved, but delta S within the limit ±1. So this interaction is allowed, and allowed through a weak interaction. So if you want to give the proper answer, then of course here itself you can comment that option number A is the correct one. So there is no need to check the remaining options, but for the sake of completeness, let us also check the remaining equations. So let's look at the next equation or next decay. So the charge here is -1, -1, 0, so charge is conserved. The spin is half for the electron and 1 for the photons. So on the right hand side you have a combination of 1/2 and 3/2. So spin is also conserved. Let's look at the lepton numbers, L mu. So on the left hand side it is a +1. On the right hand side 0, 0. So lepton number is not conserved. So we can say that straightforward, we can say that this decay is not allowed. Now let's look at the third decay, neutron decaying into proton and pi negative. So the charge 0, +1, -1 conserved. Spin half for the proton, 0 for the pion, it is also conserved. Baryon number, neutron has baryon number +1, proton has baryon number +1, pion has 0, so baryon number is also conserved. Then isospin, half for the neutron, half for the proton, and 1 for the pion. So on the right hand side, the possible values of I is 1/2 and 3/2, so this is also conserved. Third component of the isospin, for the neutron it is a -half, for the proton it is a +half, and for the pi negative it is -1, so this is also conserved. The strangeness 0, 0, 0. The strangeness is also conserved. So all these quantum numbers are conserved, but if you look at the mass, since the mass of the proton is nearly equal to the mass of neutron, so definitely the sum of the mass of proton and pion will be greater than the mass of the neutron. So this decay is not feasible due to the violation of the mass. Now let's look at the last decay, neutron decaying into pi plus and pi negative. So if you look at charge, neutron has 0 charge, +1, -1, it is also conserved. Spin, it is a half, and this is a 0 and 0, this is not conserved. Look at the baryon number, you have a +1, 0, 0, not conserved. So this interaction is also not conserved. So the only one decay is allowed, that is the Chiron. So the option A is the correct one.